Ladies and gentlemen, imagine you're an ancient sailor setting sail on the vast ocean. As you gaze out at the horizon, you may wonder, is the world flat or is it something more? This simple question has echoed through the human history, leading us on a quest to understand the fundamental nature of our world. Today, we stand on the shoulders of those ancient thinkers, armed with powerful telescopes and sophisticated mathematical models. And we're asking an even more profound question. What is the shape of the universe? For centuries, people discovered the shape of the universe. Ancient cosmologies, as mirrors of human consciousness, mythological shapes of the cosmos, Mesopotamian cosmic ocean, Hindu Brahmanda, the cosmic egg. The universe begins as a golden egg containing Brahma, who divides it into heaven, earth, and atmosphere. Chinese yin-yang and celestial spheres. Heaven is round like a shell. Earth is square like a chariot drum, which is said by Zhou Yan, who is a Warring States period philosopher, reflecting Confucian harmony. The idea of a flat universe seemed to be accepted at that time by everyone. However, things have been changed. Polish astronomer Nicholas caused an uproar in the mid-16th century by suggesting the Earth move around the Sun. But however, at that time, people always believed the Sun is around the Earth, which seems is quite a mistake to us. But at that time, by the Christian thought, people always believed that. However, it was noted in the 16th century that comets move in such a way that would crash them through crystal spheres. Replacing the spheres was the idea of epicircles, circles superposed on circles, mathematically influencing each other to result in the observed planetary motions. Finally, in 1609, German mathematician Johannes Kepler published his theory of planetary motion, which established that bodies in our solar system move in orbit shapes like ovals rather than circles. The first shift in our thinking came with the advent of Einstein's theory of general relativity. This evolutionary theory described gravity not as a force, but as a curvature of spacetime caused by the presence of mass and energy. In other words, massive objects like stars and planets actually bend the fabric universe around them. This concept opened up a whole new realm of possibilities for the shape of the universe. Instead of being a simple, flat expanse, the universe could be curved in various ways. Just as the surface of the Earth was a two-dimensional curved space, which we call a sphere, the universe could be a three-dimensional curved space. There are three main possibilities for the curvature of the universe, which are positive curvature, negative curvature, and zero curvature. You can see the picture over there. A curvature is a state of being curved like this, or the degree to which something is curved. The theory of general relativity allows three shapes, or geometries, for the universe. These are flat, closed, and open, which is similar to zero curvature, positive curvature, and negative curvature. A universe with positive curvature would like the surface of the sphere. In this scenario, if you were to travel in a straight line in any direction, you would eventually end up back where you started. It would have no boundary. It's a mind-boggling concept, but it's a possibility supported by some theoretical models. On the other hand, a universe with negative curvature would have a saddle-like shape. In this type of universe, parallel lines would diverge and the geometry would be quite different with what we learned today. The universe in this case would be definite, stretching out forever in all directions. Then there's a concept of flat universe, which has zero curvature. In a flat universe, parallel lines remain parallel, and the laws of Euclidean geometry that we learn in school hold true. For a long time, scientists weren't sure which of these models describe our universe. But in the past few decades, thanks to the groundbreaking experiments like the cosmic microwave background, which we call it CMB, radiation measurements, we made significant progress, such as a significant impact on the theories of the formation of the cosmos, advancing current measurements. But the story doesn't end there. Even though the evidence points to a flat universe, there are still many mysteries and some questions we still don't know. For example, what is dark matter and dark energy, which together make up about 95% of the total universe? Energy content of the universe. These invisible substances have a profound impact on the shape and evolution of this universe, yet we know very little about them. Now, you might be wondering, why does any of this matter? What's the point of we learn this today? The truth is, understanding the shape of the universe has profound implication for our understanding of cosmos and our place in it. It affects our theory about the origin and evolution of the universe, as well as our prediction for the future. We're like goldfish trying to map our boat shape from within, but with quantum telescopes and AI cosmology, we're finally disfiguring space-time origami folds. The universe shape isn't just about geometry. It's a signature of reality itself. We actually find that the density of the universe is such that it expands in every direction without any positive or negative curvature. In other words, we can understand easily, the universe is flat, like the ground we are stepping on. As we continue to explore the universe, we are using more powerful telescopes and more advanced theoretical models. We are getting closer and closer to unlocking the mysteries we never found in the past centuries. As far as cosmologists can tell, space is almost like really perfectly flat. The universe seems to be a three-dimensional sheet of paper. The question of the shape of the universe is a reminder of how much we still don't know about our daily life, about the universe. But it's also a testament to the incredible progress we've made in the past few decades and years. So, the next time when you look up at the night sky, remember that this universe isn't just about the stars and the moons or the things we can see by our eyes. It's a vast, mysterious, and beautifully complex identity. And we are all part of the journey to uncover its true shape. Thank you.